So the goal of this video is to find the GCF of a polynomial expression and factor that GCF out. And in particular, in this slide, we're just going to focus on a number that you have to pull out. So for example, if you have the expression 2x plus 10, what's the GCF? Okay, between those two terms, 2x and also 10, the 2x has a variable in it, right? And the 10 does not. So we're just looking at the numbers, right? So we've got 2 and 10, and the greatest common factor between 2 and 10 is going to be 2, right? Since there's no greater number than 2 that also divides 2 evenly, and we also know that 2 goes into 10. Okay, so if we know that the GCF is 2, and we want to factor this out. Okay, so the goal is 2, we know that if we take 2 and we multiply it by something else, we should be able to get 2x plus 10 because we know that 2 is a common factor to both of those terms. So it's kind of like the distributive property in reverse. So if I'm looking at this 2 as a factor of this, I look at the first term in 2x. Well, what do I have to multiply 2 by to get 2x? Well, just x, right? And what do I have to multiply 2 by to get 10? Well, 5. So now to check this, we could ask ourselves, okay, well, 2 times the quantity x plus 5, what would that be? So we would employ the distributive property here, right? So 2 times x is 2x, and 2 times 5 is 10. So we have 2x plus 10. Okay, and that checks out. All right. So whatever you're factoring out of a polynomial, when you multiply it back through that polynomial, you should get the polynomial that you originally started with. So now let's get a little more practice. So we're going to factor out the greatest common factor from each of the polynomials. Okay, so in this first one, 10x squared minus 6. So again, the first term has a variable involved and the second one doesn't. So if I'm looking for a GCF, I'm really just looking at the numbers, right? The 10 and the 6. Okay, so what's the greatest common factor of 10 and 6? Well, 6 is 2 times 3, right? 3 doesn't go into 10, but 2 does, right? And with 10, we've got 2 times 5, right? 5 is not a factor of 6. So our only common factor is 2, right? Okay, so if I pull that 2 out, then what's left? Okay, so 2 times what would give me 10x squared? Well, we'd have 5x squared, right? So 2 times 5x squared is 10x squared, yeah? And then 2 times what gives us negative 6? Well, minus 3, right? So 2 times 5x squared is 10x squared, and 2 times negative 3 is negative 6, right? Okay, so if we take what we ended with and we distribute that back through, right? So I multiply the 2 times the 5x squared and times the minus 3. What do we get? We get 10x squared minus 6, right, when we distribute that through. Okay, and that's what we started with, so that's what we wanted. Okay, in this next example, we've got 6x squared plus 12x minus 21. Okay, again, the biggest thing I notice if I'm trying to factor out a greatest common factor, the last term doesn't have a variable involved, right? So I can't pull out a variable factor. I can only pull out a number here, right? So I'm looking at 6, 12, and 21, okay? 6 goes into 12, but it doesn't go into 21, right? Is there a factor of 6 that does go into 21? Well, 3 does, right? And 3 also goes into 12. Would there be anything bigger? We've got 4 as a factor of 12, 7 is a factor of 21, but none of those go into 6, right? So 3 is going to be it. So if we factor out a 3, 3 times what gives us 6x squared? Well, 2x squared, right? 3 times 2 is 6. 3 times what gives us 12? 4, right? 3 times 4 gives us 12, so we have 4x in the middle there. And then 3 times what gives us negative 21? Well, minus 7, right? When we check this out, if we do the distribution here, so if we do the distribution here, we have to multiply that 3 times all of these terms, yes? Okay, so 3 times 2x squared is 6x squared. 3 times 4x is 12x. And 3 times minus 7 is minus 21, right? So we get the same polynomial that we started with. Okay, so in this next example, similar kind of story, right? We only have variables in the first two terms, but not in the last one. So when we're looking at 28x squared minus 20x minus 4, among all those numbers, the first thing I look at is the smallest number, right, which is 4, right? So that might be the greatest common factor if it will divide 20 and 28 evenly, and it does, right? 4 times 5 is 20, 4 times 7 is 28. So I'm going to pull a 4 out. 4 times what is 28? Well, 7, right? 4 times 7 is 28. So we got 7x squared. And 4 times what is 20? Well, 5. All right, so we got minus 5x. And then 4 times what is negative 4? Well, negative 1, right? So don't just let that term not be there, right? Because when we factor that back through, right, so when we check it down here, and we do this, and we perform the distributive property here, we should get what we started with. 4 times 7x squared is 28x squared. 4 times minus 5x is minus 20x. And 4 times negative 1 is minus 4. Okay, so that minus 1 is really important there at the end. Okay. And one last example here, similar kind of thing. We've got a little quadratic expression here, negative 2x squared plus 6x minus 10. And again, I'm just looking at the numbers, negative 2, 6, and minus 10. Okay, so when there's a negative out front, it's nice and clean if you can factor out the negative too, which will change the sign on all of the other things when you factor that out. So again, I'm looking at the 2, forget about the signs for a minute, just 2, 6, and 10. What's the GCF there? We'll start with the smallest number, 2, okay? Does 2 divide 6 and 10 evenly? Yes, it does, okay? And so the greatest common factor can't be any bigger than 2, right? Because it also has to divide evenly into 2. Okay, so if I'm going to factor, now, because of that negative out front, I'm not going to factor just 2 out. I'm going to factor a negative 2 out of there. Okay, so negative 2 times x squared would give us negative 2x squared. If I factored a negative 2 out of a positive 6x, I'm going to have minus 3x, right? Negative 2 times negative 3 is positive 6. Okay, and if I'm going to factor a negative 2 out of negative 10, I'm going to have a positive 5, right? Because negative 2 times positive 5 is negative 10. Okay, so that's the factored form. All right, so let's check this. Negative 2 times x squared minus 3x plus 5. If we distribute this through, we're going to have negative 2x squared plus 6x minus 10. Okay. All right, so notice something here in this example. When I pulled out the negative, all of a sudden, the remaining polynomial, when I pulled out the negative 2, all of the signs are opposite what they were in the original polynomial, right? Like the x squared, all of a sudden that's positive, the minus, the middle term is negative, the ending term is positive. So that's what factoring a negative out will do, right? Because just when you distribute it back through, it's going to change the sign on everything that's there. Okay. Good. So that gives us a nice little overview of just how to factor a number out from a polynomial expression.